Like all of these, I want you to read it through and try doing this problem first. I will tell you though, this one can get a little bit tricky. And so first thing I want you to do, just draw a picture to show what's going on here and label the relevant parts. Go ahead and do that, pause it, and then come back to the video, please. So this would be a way that we could draw this picture. Notice there's a lot of stuff going on in it because we have the cone and we have the water inside of it. And we got to keep track of both of those two separately. Their heights are going to be different and their radii are also going to be different. And so that's why we're keeping track of them separately here. Now, in order to be able to answer the question we're being asked about, how fast is the water level rising, we need to be able to use the information that we have. Now, in this case, what we're told is going to be critical to telling us which equation that we're going to be using is how fast that water is going into it. Notice it's a volume change again. And so since the volume is changing over time, we're going to write a volume equation, which means needing to remember the equation for volume of a cone. That volume formula is 1/3 pi r squared h. All right, now that we got that, I want to show you something. Now, this isn't going to be the final solution, but it is a very important process for us to go through and see what's going on. We're going to go ahead and now just take that equation and we're going to find the derivative with respect to time. So then I'm going to get dv over dt on the left side. And then we find the derivative of the right side. We're going to have to be using product rule because that 1/3 pi r squared is being multiplied by h. And so we're going to do original times derivative as we always do for product rule. So that's going to be the 1/3 pi r squared times the derivative of h. So that's going to be the dh over dt. Then plus, now we do derivative times original. So the 1/3 pi, it's still there because that's just a constant. So I don't want to write the pi down there. I want to make sure it's clear that it's not in the denominator. And then the derivative of the r squared is 2r dr over dt. And then that's times h. All right, great. We got a derivative. There's just a potential problem here. This one has a couple different rates in it. Let's see, this one we know that that's the 9 that's changing by, but we don't know how the height or the radius is changing over time based on the information we've been given. This would actually be a dead stop for us. This would be a place where we could not get past if there weren't another method around this type of problem. And so knowing that, we need to come up with some way to be able to do this problem without having to have dh over dt and dr over dt in my final answer. I need it to just be one of those, and there is a way that we're going to be able to do it. Now, before we do that, let's plan out which one do I want to have. Do I want dh over dt in there, or do I want the dr over dt left in my final equation? Read the problem if you're not sure. You notice the question we're asked is how fast is the water level rising? The water level change would be the height change. And so I want an equation in the very end that has the dh over dt in it, but not dr over dt. That means that if there was a way that I could go back to my original equation and get rid of the r out of it, I could do this. There actually is a way that we can do that though. So take a look at our picture over there. What I want to utilize here is this triangle right here where we know all these little pieces about it. Because in that triangle, I know that that width is 5 feet, the radius, and I know that the height is 10 feet. I can actually use that now to write a proportion because I know that the radius over the height equals 5 over 10. Remember, I'm trying to get rid of the r out of this. So if I can figure out what I can plug in for r to make it go away, then I'm going to be in a good spot. So I want to take this equation now, solve it for r. So I'm going to go ahead and cross multiply like I normally would. By the way, you actually could just multiply both sides by h, but I'm going to go ahead and cross multiply. So that's going to give me 10r equals 5h. And then again, I'm trying to get the r by itself. So I'm going to divide both sides by 10. and that gives me 0.5 h. Now that I know what r equals, I'm going to take that value for r, and I'm going to plug it in for r. And then once I've replaced r with that 0.5 h, then I'm just going to simplify this down a little bit. And the whole thing becomes 1/12 pi h cubed. Now, I know somebody out there is wondering, okay, well, why 1/12? Where did that 12 come from? So if that's throwing you off, I'm going to go off on a little side here, show you where I got that 1/12. That 1/12 comes from doing 1/3 times 0.5 squared. But 0.5 squared may be a little bit trickier. So rather than thinking of it as 0.5, I instead thought of it as 1/2. Because then I could say, well, that's going to be 1/3 times 1/4, because when you square a fraction, you square the top and square the bottom separately. And then I'm multiplying the fraction, so multiply straight across the top. 1 times 1 is the 1. And multiply straight across the bottom. The 3 times 4 gave us the 12. All right, so now that I've taken my equation and written it only in terms of h, now when I find the derivative, I'm going to end up with something with dh over dt in it, but not the dr over dt. So it's actually going to allow us to figure out our answer. So let's go ahead and do that now. Find your derivative of this equation. And so we take our derivative with respect to time, and then, yeah, I'm going to go ahead and clean that up just a little bit again, because I see like that 1/12 and the 3, those can combine nicely. And so 3/12 becomes 1/4. All right, now let's go ahead and start plugging in. And the first thing I need to plug in is my dv over dt value, which comes from this 9 feet cubed per second. Now, take a moment, think it through. Should this be a positive or a negative 9? Okay, so how do we know? The 9 feet cubed per minute that the water is coming in, it's actually entering the tank in this, which means that because it's being added to the tank, it's adding to the volume, and therefore your volume should be positive. So yes, we do that as a positive 9. But always think that through, or it could possibly throw you off on some of these very, very easily. And then the last thing we have to plug in is the h value. Now, be careful when we're talking about this h value, because there's a couple different heights involved here. We have the height of the water, and we have the height of the entire cylinder. Which one of those are we talking about here? Well, because we're looking at how fast is the water level rising, that would be this value right here. Since that is the height of the water, that means that this height must also be the height of the water, which we know from up here is going to be the 6 feet. So plug the 6 in there. From here, go ahead and just solve it now for dh over dt. And when we solve it through, we should be getting about 0.32 feet per minute. And do pay attention to your units. A lot of these are measured in things like feet per second. This one wasn't seconds though. This one was in minutes, so do pay attention to which type of time it is and what type of units it is in each of the cases, because of course it does make a difference.